Assalam students. Today's topic is going to be about variation of G with altitude. Now, according to the definition of altitude, it is the distance from the surface of the earth. Now, in this case, we are going to start with the derivation of the value of G with the altitude, and that was basically G H is equal to GME over R square, or you can say simply a small r square. Now, in this case, what he's trying to say that this is our Earth, and this is the radius of that Earth, which is represented by r over here. Now, if a body is placed on this Earth, then the value of g can simply be calculated by mg, is the weight of that body, equal to the gravitational force of the earth. Now if we equate that, that means they are balancing each other, and the action and reaction are equal to each other. So the value for the gravitational force is gme m, which is the mass of the box or mass of the body, now divided by re, which is the radius of the earth. So this m and this m basically cancels out, and we get the value of g, which is equal to gme over r square. So this is how the formula came into being. So let's go through the slide again. So this is the formula G, where the G is the gravitational acceleration, is equal to G constant value, having a value of 6.6 into 10 to the power minus 11 Newton meter square divided by kilogram square, where m is the mass of the earth, which has the value of 6.0 into 10 to the power 24 kilograms, and r is the radius of the earth, which has the value of 6.4 into 10 to the power 6 meters. Now in this case, we have to understand with the help of a diagram. In this equation, he says the equation shows that the value of acceleration due to the gravitation depends upon the radius of the earth. That means all of these values, that means the value of g, the value of the mass of the earth, remains constant, but the only thing which can change in this whole scenario is basically this r. Basically it is the distance between the two masses now, that how much distance is from the center of the mass to the center of the earth in this case, and that is taken out to be r, small r. Now it all depends upon that. Now let me clear this out a little bit. Now in this case, if we move the body m to a certain height, let's say h, then it says the value of g is inversely proportional to the square of the distance or radius of the earth, but it does not remain constant. It decreases with altitude. The altitude is the height of the object or the place above the sea level. Here we have the definition of altitude. Altitude is the height of an object or place from the sea level. The value of g is greater at sea level than at the hills. Now it is obeying the law of gravitation, from which we have derived this formula, that g over here is basically inversely proportional to the r square. So this is the formula which we are talking about. So as we move away from the objects, the value of g will basically decrease, and that is why we are saying that as we move away, the value of g is decreasing. So he's saying the value of the height, or the, let's say, a mountains over here, so the value of g will be less. Okay, the value of g will be less as compared to the value of g. If we are drawing let's say ocean over here, the value of the g will be more in this case, because the radius in this case is larger, so the value of g is less, whereas the value of g is less in this case, because it is more in this case, as the radius is less. Now consider a body. Let's do experiment about a body, um, which is of mass m and altitude h as shown in figure. The distance of the body from the center of the earth becomes r plus h. That means this much distance is known as r, which is the radius of the earth, and plus we have introduced a new height to that body, which is h. So it has this much distance, putting the value of over here. So this total distance from here to here is a small r. That means small r is equal to h plus capital R. Now, in this case, he says, what will be the value of G? Of course, it will be less than the value of G at the surface of the Earth. Now, let us give it a formula, and how can we derive that formula? Is that therefore using the equation, the same equation over here, but over here we have included a certain height over here. The certain height is included, and we are giving that height a name, which is also included the radius of the Earth, which is small r. So in this case, we'll say that G, which is the gravitational acceleration, is equal to gme over r plus h whole square. Now, in this case, let us do an experiment. If we take a body, the same body over here, let's take the mass of this body and move it uh, as much as r. So let's take it far away from the earth as much as this r. So this is r and this is r. So the total distance from the center of the earth is 2r. So he says, according to the above equation, we come to know that the height is equal to one earth radius above the surface of the earth. G becomes 1/4 of its value on the earth. Now, let us see how this goes. Let's say this is the formula. GH is equal to GME over R plus H whole square. Now here we have said that the height which is above the surface of the earth is equal to the radius now. So putting the values of this in the formula, what do we get? GME over R plus R whole square. So let us change this value of G now. It is changed from the original value now. So it will be equal to G dash is equal to GME whole divided by 2r whole square. Now, this formula is quite similar to this formula, but there is 2 square involved in this one. Now, if we separate the 2 up now, in this case, it will be equal to, let me clear that out a little bit. So G dash will be equal to GME divided by 2 square into R. Now, this is the case. So in this case, this much part, which is over here, is equal to GH basically. So putting the values, instead of writing this whole thing, we are putting the value of GH. It will be 1 over 2 square into GH times. So we can say G dash, the new value of G at the distance 2r from our Earth's surface, it will be 1/4 the value of the G it was on the surface of the Earth. So here we go. So that is what he was saying. According to the above equation, we come to know that the height of equal to one Earth radius above the surface of the Earth, G, becomes 1/4 of its value on the surface of the Earth. And we have proved it mathematically also that it is 1/4 the value of the value of the G at the surface of the Earth. Let us try another distance as well. Let's take the mass further away from the Earth's surface. He says similarly at the distance of 2 Earth radius, which is over here, that means 2 times the Earth radius from the surface of the Earth's surface, the value of G becomes 1/9 now, or 1/9 of its value on the surface of the Earth. Let us revise the whole procedure again, but the value of r has changed because now the distance has changed from 2r to 3r. So there is 1r over here, 2r over here, 3r. That means the total of 3r distance is from the center of the Earth. Now in this case, let us solve the formula again. So it will be equal to GH is equal to GME, was the original formula, divided by R plus H. But now the H from the surface of the Earth is how much? It is equal to 2R. So 2R is equal to H. So our new formula will become G dash H, that means the change which we have done from let's say 2R to 3R, it will be GME divided by R plus 2R whole square. So R plus 2R will become 3R. Let us solve this equation simply so that we have a clear cut idea. So G dash will be equal to GME divided by 3R whole square. Now, if we take the 3 square onto uh, separately like this, 1 over 3 whole square into GME divided by R square right over here. So this whole thing, this part over here will become the value of GH. So the value of GH dash, that means the change in G, will be 1 over 3 square into GH. If we put in the values of this square part now, the value of 3 square is equal to 1/9. That means G will decrease, GH, GH will decrease 1/9 times when it is taken uh, 3 times the radius of the earth from the from the center of the earth. I hope you enjoyed today's lecture as well, and this is the answer to our question as well, 1/9 of its value. I hope you enjoyed this lecture. Inshallah, we'll meet again. Allah.